Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of the chapter continuity. Limits and continuity are always interlinked, and we need the concept of limits to understand the concept of continuity. Now basically what is the meaning of this word continuity? Okay. So that means a function or anything is continuous, alright. So there is a continuity, there is a continuous process that happens there, alright. When you come to mathematics, if you have a function which is continuous, alright, so there is no break in that function. You can have a function which is continuous that way also. You can have a function, alright, which is continuous, there is no break in that function. So that is the crude understanding of it, alright. But if you want to understand it mathematically, then we need to go through those conditions. Before that, what is the opposite of continuous? Discontinuous. Let me show that to you first. See, imagine you have a signum function. Okay. So what is a signum function? This is the signum function, if you remember, alright. So when x is positive, y is equal to 1, correct? F of x is equal to 1, and when x is 0, f of x is 0. And if x is minus 1, or if x is negative, I am sorry, if x is negative, f of x is minus 1, right. So if it is minus 0.1, then it will come here. If it is minus 0.5, it will come here. If it is minus 1, y will come here, correct. And if you have 0.1, then it will jump to 1. If x is equal to 0.5, then y is 1. If it is 2, y is 1. If x is 3, y is 1, correct. But at x is equal to 0, y is also 0. Therefore, this is a blank, this is a dark space, okay, and these are the blank spaces. It starts immediately after 0. At 0.000001, y is 1. Okay, so in order to make that difference, there is a blank space and dark space here. Now, the question is it continuous? Alright, you come from minus infinity, okay, and you come in a straight line, okay, you stop here, and then at 0 you go to 0, and then from 0.00001 you start from 1, and then you continue. So there is no connection whatsoever between minus 1 and 0 and 1, alright. So at 0 you have a breakage there. The function is broken. It is not a continuous graph. Therefore, signum function is discontinuous at x is equal to 0. At all other points, it is continuous. All right. Keep that in mind. I will come back to that. Now, let us understand the conditions. Well, so first, a function f of x is said to be continuous at a given point x is equal to a. If f of a exists, f of a is the function value at the given point. So if x is equal to 0, then f of 0 must be a real number, it must exist. It shouldn't be infinity, it shouldn't be a number which is not defined, it shouldn't be a function which is not defined at a. Well, so a function f of x must be defined at the given point. Alright, next. Second point, the limit of f of x as x becomes a, as x tends to a, as x approaches to a must exist. When do you say the limit exists? Only if the left hand limit and the right hand limits are equal. What is the left hand limit? limit of f of x as x tends to a minus, right, and right hand limit is limit of f of x as x tends to a plus. So left hand you are approaching to 0 from left hand side and you are approaching 0 from right hand side are the left hand and right hand limits, and they must meet at the same point. Here they are not meeting, you see. As you come from left hand side you are ending up to minus 1. As you go from right hand side you assume that you are reaching 1 at 0, correct. So they are not matching, you are getting minus 1 and 1, they are not equal. If they are not equal then it is discontinuous. Okay, so that is the discontinuity of the first type. The second type, if the limit value, if at all it exists, let us say both meet at the same, the assumed points are same, they look as if they are meeting at the same point when you come from left and right, and hence left hand and right hand limits are equal, and hence the limit of the function at a exists. The third condition says that that limit which exists must be equal to the function value at a. All right. So then only it will be a continuous function at x is equal to a. Now let us keep this function in mind. Okay, the signum function, and how it is defined. Signum function you have got f of x is equal to minus 1 if x is less than 0, 0 if x is equal to 0, and 1 if x is greater than 1. So that is the definition, and you have the graph there. Now first let us check at x is equal to 0 whether this function is continuous or not. From the graph it is evident that it is not continuous. Let us prove it with the mathematical conditions. Now you have got the first condition that says f of a must exist. Now what's a? A is 0, so hence f of 0 must exist. What is f of 0? When x is 0, when x is 0, what is f of 0? Is 0, so that exists. 0 is a real number, it exists. Alright, so first condition satisfies. Now what about the second condition? You have to check whether limit exists or not. For that sake you must find the left hand limit. So let me write the left hand limit here. Now what is the left hand limit? As x tends to a is 0 now, so 0 minus, what is f of x? Alright, so what is the meaning of 0 minus? 0 minus is all the values which are less than 0. So for all the values which are less than 0, for all the values of x which are less than 0, f of x is minus 1. So now I must replace this f of x with the minus 1. Alright, so that's my function. Now do you have a variable here? You don't have x, you don't have a variable, so you don't need to substitute that 0 there. Alright, you don't need to substitute that 0, so the value is the constant itself. So left hand limit is minus 1 now. What about the right hand limit? So the right hand limit is 0 plus, and what is the meaning of 0 plus? All the values which are greater than 0. So for all the values of x which are greater than 0, f of x is 1. So in place of f of x I must write 1. Okay, so let me write that. Now once again, what is the limit of this? It is 1. So left hand and right hand limits do not match. So if they don't match, then limit does not exist. So if limit does not exist, then it is a discontinuity of the first type. So the function is not continuous at 0. Well, so that's an example which shows, which explains the conditions, all right, which must be satisfied to make a function continuous. Well, I hope you understood that. Now that is at a given point. For example, this is at x is equal to 0, we have checked. Now what if, what about the word continuous. When do you say the function f of x is continuous? Nothing mentioned, no point mentioned here. So that must be continuous everywhere. So at every point in its domain, it must be continuous. So it must be continuous at -1, -2, -3, -4, -5, everywhere 1, 2, 3, 4, 5, even at 0.1, 0.001, 1.1, 1.12, all those points it must be continuous. There shouldn't be any breakage. Alright, there shouldn't be any discontinuity, then only you can say the function is continuous everywhere. Simply we say the function is continuous. So if you hear the word continuous, it means that it is continuous everywhere. Alright, so if a point is mentioned, then only at that point we must check. Alright, so now what about signum function? Is it a continuous function? No, it is not. Why? Because it is not continuous everywhere. Where it is not continuous, at x is equal to 0, it is not continuous. So there is a point of discontinuity. So as a whole, the function is not continuous. Well, I hope you understood that generalization. So that's just generalization from the particular cases. Well, so that's it for today's synopsis class. From the next class, we'll start working out the examples. So thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.